La Silla Observatory Chilan 2009. In the arid mountains of the Coquimbo region, astronomers peer deep into the cosmos and identify a potentially habitable exoplanet orbiting the red dwarf star Gliese 667c. The planet, designated Gliese 667cc, is categorized as a super-Earth, a rocky world larger and more massive than our own. Most intriguing of all, it lies firmly within its star's habitable zone, the so-called Goldilocks region where temperatures may be just right for liquid water to exist. While no spacecraft has seen its surface and no telescope has detected definitive signs of life, scientists can model its environment and imagine what evolution there might produce. On a planet with stronger gravity than Earth, life would adapt accordingly. Increased gravitational force would favor shorter, sturdier organisms, built close to the ground to prevent injury from falls. Tall, fragile structures would be inefficient. Compact, reinforced bodies would dominate. Meanwhile, because Gliese 667c is a dim red dwarf only, a fraction as luminous as our Sun, the planet would exist in a world of twilight. Red dwarfs emit most of their radiation in the infrared spectrum, meaning the skies might glow in deep crimson hues. Life forms evolving under such conditions might develop enormous eyes capable of capturing scarce, visible light, or perhaps entirely different visual systems attuned to infrared wavelengths. Some scientists speculate that alien creatures there could perceive heat signatures as clearly as humans perceive color. To ancient astronaut theorists, such speculation sounds eerily familiar. Descriptions of short beings with large heads and oversized black eyes closely resemble the so-called greys reported in modern UFO encounters. Could the evolutionary pressures of a high-gravity, low-light world naturally produce such forms? Or are these similarities coincidental, shaped more by human imagination than astrophysical reality? While mainstream science demands empirical evidence, the rapid expansion of exoplanet discovery has undeniably transformed our understanding of the universe. The breakthrough began in the 1990s, when astronomers Michel Mayor and Didier Queloz identified the first confirmed exoplanet orbiting a Sun-like star discovery that earned them the Nobel Prize in Physics. Since then, more than 4,000 exoplanets have been catalogued, with thousands more candidates awaiting confirmation. Today, astronomers estimate that nearly every star in the night sky hosts at least one planet. Some of those worlds are gas giants, others scorched infernos, but a fraction may resemble Earth. The deployment of the James Webb Space Telescope has revolutionized the search. By analyzing starlight filtered through distant atmospheres, Webb can detect chemical signatures such as water vapor, methane, carbon dioxide, and possibly even oxygen molecules that, on Earth, are closely associated with life. Yet humanity's search for extraterrestrial life did not begin with distant stars. It began within our own solar system, most notably on Mars. On July 20, 1976, NASA's Viking 1 became the first American spacecraft to successfully land on the Martian surface. After a journey of 420 million miles, it transmitted the first detailed images of the red planet's landscape, rocky plains, eerily reminiscent of Earth's deserts. Viking carried experiments specifically designed to test Martian soil for microbial life. One experiment, led by Dr. Gilbert Levin, appeared to detect metabolic activity consistent with living organisms. However, another instrument searching for organic molecules produced negative results. Faced with conflicting data, NASA adopted a cautious stance. concluding that the evidence for life was inconclusive. Decades later, debate over Vikings' results continues among scientists. Human fascination with Mars stretches back thousands of years. Ancient Egyptian astronomers recorded the red planet in star charts and depicted it in tomb art. To many cultures, Mars symbolized war and bloodshed due to its crimson glow. The Babylonians associated it with Nergal, god of destruction. The Greeks named it after Ares. The Romans called it Mars, their god of war. Across civilizations, the red planet held mythological power, seen not merely as a wandering light in the sky, but as a celestial force influencing human destiny. In 1850, another discovery deepened the mystery of humanity's relationship with the heavens. French Egyptologist Auguste Mariette uncovered a vast underground complex at Saqqara, the Serapeum of Saqqara. Hidden beneath the desert sands lay a labyrinthine corridor nearly 800 feet long. Lined with colossal granite sarcophagi, each weighing as much as 100 tons, with its lid, these monolithic boxes were carved with astonishing precision, polished to mirror smoothness, aligned at perfect right angles, and transported from quarries hundreds of miles away. Mainstream Egyptology maintains that the Serapeum served as a burial site for the sacred Apis bulls. Revered as living manifestations of Osiris, yet only fragments of remains were discovered within some of the sarcophagi, while others were empty. The sheer scale and engineering precision of these stone containers continue to spark debate. How were they transported into narrow underground chambers? What tools were used to achieve such immaculate finishes? And why construct burial chambers far larger than necessary for a single animal? Nearby, the Pyramid of King Teti contains the pyramid texts, some of the oldest religious inscriptions known. These writings describe the pharaoh's journey after death, ascending to the heavens to join Osiris among the stars, often associated with the constellation Orion. To conventional scholars, these passages are symbolic spiritual narratives, but ancient astronaut theorists propose a different interpretation. That they encode memories of advanced knowledge, perhaps even contact with celestial beings. From exoplanets orbiting distant red dwarfs, to Martian soil experiments and ancient subterranean chambers in Egypt, a common thread runs through human history: the desire to understand our place in the cosmos. Are we alone in the universe? Or have we been connected to the stars since antiquity? As modern telescopes analyze alien atmospheres and robotic explorers continue to roam Mars, science moves steadily forward, grounded in data, driven by curiosity. Whether the answers lie in distant planetary systems or hidden chapters of our own past, one thing is certain: the search for life beyond Earth is no longer confined to myth. It is a scientific quest unfolding in real time, bridging ancient wonder and modern discovery in humanity's greatest exploration.